Okay, based on the graph shown in figure 3 above, describe the motion of the particle from A to E. Okay, so let us look part by parts. Yeah. Okay, look at AB. Okay, question A. Okay, there are two things you need to know about velocity graph. Okay, first of all, let us look at the meaning. Here, this one, you must know this. The gradient of the velocity graph is actually acceleration. This one you need to know. I need to highlight it. Yeah, you need to know about this. Acceleration of velocity graph. No, the gradient of velocity graph is acceleration. Another thing is you must know about this. The direction of motion. Okay. If positive velocity means the object is moving to the right. If negative velocity means object moving to the left. Okay, these two things you must know. The gradient of velocity is acceleration. Okay, let us look back to these questions. So first of all, we'll look at AB. Okay, part AB. So what do you think is this motion? First look at the gradient of velocity. It is called acceleration. So this one, we can say this one is acceleration. The gradient is acceleration, and it is a positive acceleration. Okay, positive acceleration. One more thing you need to know. One more thing you need to know is this part, velocity versus acceleration. So if the velocity and acceleration same direction, object accelerate. If velocity and acceleration opposite direction, the object decelerate. This one you must know. So yeah. Okay. So look at this part AB. So this velocity increase, isn't it? Okay. First thing you already know, the gradient of this is positive acceleration. All right. Second thing you see is this velocity is a positive velocity. Okay. Here velocity 0. Okay. That means this line is all stop. Yeah. Velocity is 0. At this line. Okay, here is a positive velocity. Here the graph on top is all positive velocity, the graph below is negative velocity. Maybe let us just label all the gradient also. Okay, this part acceleration is negative. Acceleration negative. This one also negative, and this part also this part acceleration positive. Okay. Positive acceleration, negative acceleration, negative acceleration. Okay, and the top part here all positive velocity, and the middle is 0 velocity, below is negative velocity. Okay, so one thing I want you to see here is positive velocity, the part AB, positive velocity and the gradient acceleration also positive. So both positive, isn't it? V positive, A positive. That means when both same direction, V positive, A positive, same direction, object accelerate. So here is accelerate. Maybe I should use a blue, right? This one here, this part is acceleration or velocity increase. How about part BC? Part BC, V positive, but gradient acceleration negative. Opposite direction, V positive, A negative. So when V positive, A negative, opposite direction, decelerate. So here, this BC is decelerate. Decelerate, the velocity decrease, become slower and slower. Yeah, in fact, you see from A to B, the car going faster and faster until B is the top speed. And then B to C is the velocity going slower and slower until velocity stop. Okay. The velocity stop, all right, the decelerate, and then from C to D is also the gradient is negative, so acceleration negative. Okay, but the velocity is negative. You see that? V negative, A negative, V negative, A also negative. So same direction. V negative, A negative, same direction. So object accelerate. So this part, the C to D part is object accelerate. Object accelerate means V is increasing. V is increasing from C to D, and then D to E is V is negative value. V is negative value, but acceleration positive. So opposite direction. V and A opposite direction. So when V and A opposite direction, decelerate. The object decelerate. So here this part is decelerate. So velocity actually decrease. In fact, D to E velocity decrease back to 0. Okay. Okay. So let us look at this. Now. Okay, maybe we can describe this in a graphic. Yeah, in terms of graphic, that means I use a picture to describe this motion. Okay. Let's imagine this is what kind of graph again? This is a velocity time graph. Yeah, maybe I use a object to explain. Okay, I draw a car first. I draw a car. Yeah, this is the car. Okay. Car. Okay. Yeah, this is the car. Okay. All right. Hold on a second. Okay. Now, let's talk about part AB. Yeah, part AB. Part AB. So what happened during part AB? Okay, part AB. AB is the car moving faster and faster. You see, accelerate. Acceleration, moving faster and faster, and then velocity is positive. Okay, again, maybe what is mean by velocity positive again? Positive velocity means object moving to the right. This one you must know. Okay, maybe I should write over here. Velocity positive means moving, the direction of motion is moving to the right. Yeah, V0, the time axis means it stop, not moving at all. V negative here is means moving to left. Yeah. So the graph on top means the car is moving to the right. A to B to C means the car is moving to the right. C to D to E means the car is moving to the left. The point C and E means it stopped. So it stopped 3 times. You see that? It stopped 3 times over here. Yeah. Here. Yeah. Okay. This part also is stopped. Yeah. Point C. So A and C and E. The point A and C and E, the car stop, not moving. Okay, velocity 0. Okay, so we can roughly say like that. A to B is moving to the, is velocity positive, is moving to the right. Yeah, it's moving to the right. So I can imagine like this. Yeah, using this car to describe. Okay, for AB is moving to the right and also become faster and faster. So I can draw like this. It become faster and faster. Yeah, become faster and faster. You see that? Becoming faster and faster. Okay, it is moving to the right. It's moving to the sorry, what is this? Okay, so now it is moving to the right, velocity positive, and it is acceleration. Okay, acceleration. Okay, now okay, how about this one, B to C? B to C means is moving, also velocity positive. Velocity positive means it's moving to the right, but it's deceleration, becomes slower and slower. So it becomes slower and slower until it stops. Yeah, also moving to the, so okay, this one, okay, becomes slower and slower. Yeah, becoming slower and slower. Right, becoming slower and slower until finally it stops. You see that? It starts from zero velocity. It stopped from zero velocity until this is we can say maybe I draw out the whole motion and describe to you. Yeah. All right. Let us continue. Yeah. I've drawn the picture for you. Okay. So let us look at this one. Yeah. The motion. Yeah. Describe the motion of the particle from A to E. From A to E. So look at the part AB. AB is a positive velocity. Okay. Okay. Part AB is a positive velocity, means the object is moving to the right. Okay. And then it has acceleration, because we know that we see that velocity increase, isn't it? Velocity increase, acceleration. Just now we already discussed this one accelerate, this one decelerate. Yeah, velocity increase, decrease, become zero. Here velocity increase again, but in opposite direction, moving to the left. Velocity decrease again, become zero. Okay, we already discussed about this. So I draw out for you the motion here. So you look at this part AB. Here the graph is above the time axis. The graph of velocity is above the time axis, so velocity positive. It is moving to the right. Okay, it is moving to the right. This is the AB. It's moving to the right, and then the velocity increase, acceleration, become faster and faster. Look at the red arrow, become faster and faster, moving faster and faster. Okay. Okay, so we BC is becomes slower and slower, but it's still moving to the right because velocity is positive. You see, velocity is positive, so the graph velocity is positive. The graph is still velocity positive, means the car is still moving to the right, but it's deceleration. Deceleration, velocity decrease until become zero. So you can see the car moving to the right, but velocity decrease. Yeah, it's very fast, but decrease until become velocity zero. So at C, they stop. You know, here you have 3 stopping points because the graph touches the time axis 3 times or thrice. Okay, it touches the time axis 3 times. The graph touches the time axis at A, at C, and E. So this A, C, E, these are the 3 points where the car stopped. Okay. So A, the car stop. C, the car stop. Yeah. And then finally E, the car also stop. You see that? Okay. So B to C is still moving to the right because velocity positive. And then but velocity decrease, decelerate until become stop. Okay. Now C to D. C to D, velocity is negative because the graph is below. The graph is below the time axis, so velocity negative. So the car now is moving to the left. You see that? Point C is changing direction from positive velocity to negative velocity. Means here it changed direction already. Point C is where it changed direction. Before C is moving to the right, but after C it is moving to the left. This is the thing you should know. Okay. After C, the velocity become negative, so it's moving to the left. So point C is where it changed direction from right to left. Okay. Now C to D is the car is moving to the left. Okay, car is moving to the left because velocity negative. And then here, just now we learned this one acceleration negative, but because A negative, V negative, same direction, the object accelerate. So it becomes faster and faster. You see, the velocity increase, but increase in negative value. Increase in negative value. Yeah. See, so it become more and more negative. The velocity become more and more negative. Means it become faster and faster, moving to the left. Become faster and faster, moving to the left. Okay. After that, after D is a very high speed. D is very high speed to the left. After D is velocity decrease again. You see, velocity decrease until back to zero. But it's still moving to the left. The car is still moving to the left because velocity negative. But the velocity decrease. and then back to 0. Yeah, back to 0. So it stopped over here. So you ask me, do the car return to the origin? Okay, this is the origin part. Yeah, this is the origin, the point A, the origin. The car did move forward and backward, but is it the car return to the origin? Okay, I forgot to draw the head over here. Yeah, there is a head. Okay, is the point E back to point A already? Is the point E back to point A? Do the car return to origin? We know that it go forward and then it also go backward. ABC, the area ABC is the distance it moved forward. Area CDE is the distance it moved backward. Okay, is it the car return to the origin? Okay, look at this area. This area, yeah, I want you to look at this area here, this area. This blue area compared to the yellow area. Compared to the yellow area. So blue area is this we can say this is a positive displacement. The area, if the area shows displacement because it's a velocity time graph. Okay, for velocity time graph, the area under velocity graph is called displacement. This one also you should know. Area below velocity. You see this one picture here already carry all the gist, all the most important thing in this graph. It already, one picture here already represent everything's important for this graph. So you just have to apply the knowledge here, then you can solve everything. Okay, so what I want to say is area under the velocity time graph is the displacement. Yeah, this is the thing you should know also. Yeah, the area under velocity graph is displacement. Okay, now look at this blue line. Yeah, this blue area. So this area is the displacement, but this area is above the time axis. Above the time axis. Okay, above the time axis. So this is okay. Above the time axis. So this is a positive displacement. Means the area ABC means positive displacement means I should just this is the one. This is area ABC. Area ABC means how far it moved to the right. How far is the positive displacement? How far is, this is ABC. How far the car moved to the right? What's the displacement to the right? Positive displacement means what's the amount of displacement to the right? Okay. Now how about CDE? CDE is area below the time axis. Area below the time axis is negative displacement. That means how much displacement to the left, how much the car moved to the left. Okay. How much is the negative displacement? So this is the, okay, I should highlight this one also. This is the area, this is the displacement to the left. You see that? The blue area is how far it moved to the right. The yellow area is how far it moved to the left. This graph, actually I already show one animation. I make one beautiful animation to show you in my concept video. If you look to my concept video, I already explained all of this. Okay, but I still wondering why you don't look at my video and you still don't understand. Yeah, you must look at thoroughly all my videos. Okay, so this one, area CDE is how far it moved to the left, the negative displacement. Okay, so you ask me the question, is the car returned to origin at point E? Has the car returned to origin? That means return to point A when the graph reaches E. The car returned to point A? The answer is no. Why? Because this area, okay, I want to tell you, the area, I just want to show you this one. The area ABC is less than area CDE. is less than the area CDE. You see, you look at this area. This is how far it moved to the right. ABC is how far it moved to the right. CDE, the yellow area, is how far it moved to the left. How far it moved to the right? More area. How far it moved to the left? Less area. So, it moved to the right more than it moved to the left. The car moved to the right more than the car moved to the left. So, it moved to the right more than the car moved to the left. So, the car, in the end, didn't return to origin. Okay? The car stopped in the front of origin. This part is the origin. Okay, the car stopped at the front. The front of origin. The front of origin. By comparing the area, you want to know whether return or not? Compare the area above and below the graph. Yeah, you total them up. We can say here is S positive, here is S negative. So we total them up. Yeah, we have just put this as S1, this one as S2. S1 plus S2. We total up this one. This is a positive value plus a negative value. See, you get 0 or not? If you get 0 or not, if you get 0 means it return to origin. Return to origin. But if not 0 means it do not return to origin. Yeah, of course, this one we can see this area is not the equal. The area is not equal, so it do not return to origin. The answer is it doesn't return to origin. Okay, that's enough. So I hope that you can answer, describe in words. Describe the motion from A to E in words. Okay, you should say like that. A to B. Okay, A to B means what? Yeah, maybe I can write over here. A to B means moving. You should say the direction, moving to the right. Yeah, you should say moving to the right with acceleration. With acceleration, moving to the right with acceleration. You also can okay, moving to the right with acceleration. And then you can say for part BC, for part BC is yeah, you know, maybe I should can type it out here. Sorry for waiting. Okay, I written down here. So if you look at AB means the car is moving to the right. Yeah, car is moving to the right with acceleration, become faster and faster. Okay, you should write like this. And then BC is the car is still moving to the right. It's still moving to the right with deceleration until it stop at point C. Velocity 0. And then CD is the car is moving to the left. The car is moving to the left with acceleration. Yeah, with acceleration. And then DE is the car moving to the left. The car is moving to the left with deceleration. Yeah, decelerate until it stop at point E. That's it for the part A. Now sketch the graph A, acceleration time graph. Yeah. So how to sketch the acceleration time graph? So I have already written here. Yeah, this is the question B. Sorry, this is question B and this question C. Now how to draw? Question B is acceleration time graph. So how to draw the acceleration time graph? Okay, acceleration time graph. When you draw the graph, remember you must put the symbol and unit. You must put the unit meter per second square, and meter. Time is second. You must put all the unit. Cannot just put A or S. Cannot. You must put the unit also. Another thing about the question C, XT graph is actually the displacement time graph. Yeah, XT graph is ST also. You can write as X, you can write as S. Okay, displacement or position is the same. Yeah, S or X can both accepted. Now look at the question A. B asks us to find acceleration time graph. So how to draw? Okay, again very simple. So just yeah, you know, acceleration is dv/dt, is the gradient of velocity time graph. So all right. So now this is okay, to draw like that. So this is acceleration positive, this is acceleration negative, this one also acceleration negative, this one acceleration positive. So A and B are positive, positive. So you know, for acceleration time graph, the graph on top is positive, the graph below is negative acceleration. Positive acceleration, negative acceleration. Okay, so positive acceleration means this one over here, yeah, and then negative acceleration excuse me, negative acceleration is below, the graph is below. Now how about CD is less negative, yeah. B and C and C and D, BC and CD both are negative gradient. You see that? Negative gradient. So both are negative acceleration. So but CD less steep, BC more steep, CD less steep. So the graph is a bit above, a bit on top. Okay, less mean this one less negative, this one more negative, less negative. And then this one DE almost parallel to AB, isn't it? Also positive acceleration. So over here, yeah, almost equal to AB. Okay, that's it. This for acceleration time graph. Now how about the displacement time graph? How to draw the displacement time graph? This is a bit tricky. I would say a bit tricky, but it's easy, still can do. Yeah. Now one thing to remember is the velocity. The velocity is actually the gradient of displacement time graph. Remember, velocity is the gradient of displacement time graph. Look at this. Where's my notes? No, sorry. Here, this one. Remember? This one also you must know. You see, everything in one notes. Gradient of displacement time graph is velocity. Gradient of displacement time graph is velocity. This one you must know. Yeah. The gradient of the graph is velocity. The gradient of displacement time graph is velocity. So how to draw this? Yeah, how to draw this? Okay. You must refer to the picture also, the diagram, the motion. So look at part AB. Part AB, I use this line to help me. You see, I use this line to help me. This is the point B, point C, point D, and point E. Okay, and then the velocity is the gradient of this graph. Okay, velocity is the gradient of displacement graph. Okay, now AB. I want to ask you, AB. AB is going to which direction? Yeah, going to the right, because velocity positive. I already explained about moving to the right, moving to the left. I don't want to further elaborate. Okay, I already draw a picture for you. You should appreciate. You should use the picture only here. So velocity positive. This one ABC is all moving to the right. CDE is all moving to the left because of velocity positive and velocity negative. Okay, so I draw a picture here already. And then you should know this one become faster and fast. A to B become faster and faster. B to C become slower and slower until it stop. C to D become faster and faster but in opposite direction. D to E becomes slower and slower until it stop. Okay, we should understand that. Okay, maybe I should add one more. Just add this. This one velocity increase, accelerate. This one decrease, decelerate. This one velocity increase. This one decrease again. Okay. Okay, now look at this this graph. How to draw? Very hard to draw. Displacement? No. If you understand, it's easy. Okay, this velocity is the gradient of displacement graph. So this AB is moving to which direction? AB is moving to the right. You see, AB is moving to the right, but become faster and faster. It's moving to the right. So displacement should be, this is the origin. You see? Displacement graph, this the time axis here is called origin. It's the origin. So it's moving to the right. So that means it's going to the right side of origin. So the graph should go to the right side of origin instead of going down. You understand? It should go. Sorry. It should go to the side. So it becomes faster and faster. Velocity increase. That means this velocity is actually gradient. This velocity is actually we call it the gradient ds dt. Gradient is ds dt increase. This one ds dt decrease. This one ds dt increase. This one ds dt decrease. The gradient, you understand? This velocity increase, means the gradient increase. So the gradient of the displacement graph should increase. It's a curved line. It's a curved line. Is it curved upward or curved downward? Is it okay? I know it's going to the right hand side of origin. So is it mean like going this way or is it going this way? Which one? The first one or second one? Which one? Of course, it's the first one, because the gradient, look at the gradient, it's becoming from zero velocity. The ds dt become increase. The ds dt become increase. So it's the first one. See, many concept here. So it should curve upwards. The graph should curve upwards. Yeah, going to the right hand side. Like that. Yeah. So it's curving upwards. So you see the velocity, the gradient velocity here is 0. And then here, going up here, going up here, going up here, velocity here increase. You see that? Velocity increase. But then, look at BC. BC is going slower and slower, isn't it? Going slower and slower, but it's still moving to the right. Still going away from origin. Going away from origin. So, the graph is going up or going down? Is it going nearer to origin? This is the origin, remember? This part is the origin. B to C, is it going nearer to origin or going away from origin? Going away from origin. So the graph should go up some more. Isn't it? The graph should go up some more. So this one is gradient decrease. Gradient decrease. So it's going which way? Is it gradient decrease? Is it means that the increase some more, or is it going like this? Is it the gradient increase? Yeah, which one? Which one? Yeah. Is it the gradient increase? Is it the gradient increase or gradient decrease? Is it gradient increase or gradient decrease? Like that. Which one? Which one? Is it the first one or second one? Of course, it is the second one, because the ds dt decrease, gradient decrease. So it's curved downward. You see that? Become flatten and flatten. So the graph should curve like that. Like that. You see that? Like that. Okay? The gradient ds dt decrease. So that means you see the triangle. The triangle decrease. The triangle decrease until velocity 0 back again, horizontal. So at point C, this is point C already. Point C, just now is point A, this is point B. Point C is stop. You see that? The gradient stop. Point C, the gradient becomes stop. Okay? Now it's very far away from origin. This line is the origin. Okay, very far away from origin. Now it's moving. C to D is moving back to origin. You see that? It's moving back to origin, but it's becoming faster and faster. Becoming faster and faster. So how the graph is look like? Becoming faster and faster, the gradient increase. So is it going this way or this way? Which one? Is it the first one or second one? Which one? Which one gradient increase? Which one gradient increase? Which one gradient increase? The first one gradient decrease. Gradient decrease. The second one gradient increase. But negative gradient. You see that? Negative gradient, because velocity is negative. Velocity is negative. So it is the second one, because the become faster and faster means the gradient increase. So it's not the first one, it's the second one. So the graph for this one is like that. It's like that. You see that? So you can see the gradient increase. The gradient increase. So from 0 and then becoming steeper and steeper, semakin cerun. Becoming steeper and steeper, the velocity increase. Velocity increase. Velocity become the gradient increase. The gradient increase becomes steeper and steeper. You know like a mountain. You know what is a mountain? You know, you go to you watch the person who climbed the mountain, like the Tom Cruise. Tom Cruise can climb without a rope. Can climb without a rope. Which part is the most dangerous? This part, isn't it? This part. Climb with the Tom Cruise climb the mountain without a rope. It's so steep. It's so steep. The gradient, the DSDT, the gradient is so high. If this part is if like this, the DSDT is 0. Over this part, the gradient is this one is not steep. Over here is safe. Yeah, but Tom Cruise like this part. Very steep, very high gradient, very dangerous. Yeah, too young and too dangerous. So this is very high gradient over here. Understand? Very high gradient. Yeah, the very high gradient. So here is very high gradient. Yeah, so velocity become from 0. You see, velocity from 0 or gradient from 0 increase to high maximum gradient here. Maximum gradient. Very high velocity. And then D to E. What's the D to E? D to E means moving to the left. It's moving to the left. It's moving to the left some more. Going nearer to origin. This is the origin, right? So the graph should going nearer to origin. So the graph should go down or go up. Of course, go down because going nearer to origin. So not going away from origin. So go nearer. But it's not a straight line. It's not a straight line. Look at the velocity. The velocity decrease again. Velocity decrease again. Velocity decrease. Velocity decrease. So that means I become slower and slower. Becoming slower and slower. It becoming slower and slower. So becoming slower and slower. So that means the gradient decrease. The gradient decrease back to 0. The gradient decrease. So which line is it? Is it like this or like this? Which one? The first one or second one? Which one? Of course, if the first one, it is from 0 gradient become high gradient. But you see, this one is from high gradient become lower gradient. So it's the gradient decrease. Gradient decrease, it means the curve become horizontal again. The curve become horizontal again. Becomes 0 gradient. So it's the second one. So not the first one. It should be the first one. You understand? Like that. So you look at the gradient. Look at the gradient. The gradient is decreasing from maximum to back to 0 velocity, back to horizontal line. Back to horizontal line. And why do I do not draw the graph go back to origin? Why the graph is stopped in front of origin? Why is it stopped in front of the origin? The time axis here, you know, the time axis here is the origin. Okay, why the graph do not go back to origin? I told you already, because of the area, how far it moved to the right. The distance it moved to the right is more than the distance it moved to the left. So the car didn't return to origin, but it stopped in front of origin. It stopped in front of origin. So it didn't return to origin. If you draw your graph, go back to origin, then you are screwed. You are wrong. Yeah, if you go back to the origin, then your graph is a big wrong there. Okay, a big wrong there. So it should actually stop in front of origin, because the area backward is less than the area forward. Okay, the area backward is less than the area forward. Remember, the area under the velocity graph is displacement. Okay, so the answer is not going back to origin, but the graph stop in front of origin. Okay, so this one gradient increase, gradient decrease. Okay, remember the velocity as the gradient of displacement graph. This one gradient increase, this one gradient decrease back to become 0, and then gradient increase again, gradient increase again, and then this one gradient decrease again back to 0. Another thing is you should know that this part velocity positive. Yeah, here velocity positive means velocity positive. All this gradient is a positive gradient because it's moving to the right. And and then this part is velocity negative, and here also velocity negative is moving to the left. This negative gradient, you see, this one all negative gradient means the car is moving to the left, back to origin. Okay, so I think I have explained actually explained everything already. Yeah, in this video, in previous video, in all the video, I explained the same thing. I really hope that you look at my video seriously. Okay, bye.